these pink numbers are perfect squares, and these perfect squares are going to be super useful for us today in helping us to simplify square roots. So we want to make sure we know these perfect squares really well. So 9 is a perfect square, 16 is a perfect square, 4 is a perfect square. That's not pink, but it's there. Okay. Perfect squares are nice because when we have square roots, so say I want to have the square root of 49, well, this 49 is really 7 squared. And the square root and the square end up canceling each other out. The square root and the square cancel out, leaving 7. Maybe you knew. What is the square root of 49? 7. Well, that's why. Because the square root and the square cancel out, all right? We're just left with the 7. And so we can say, hey, what's the square root of 64? What's the square root of 64? 8. What's the square root of 169? 13. Okay, so having a list of perfect squares is pretty handy. And when we want to simplify square roots, we want to try and find the biggest perfect square that we can. So we're going to get there in just a second. But first, we want to talk about solutions. So here we have, what are the solutions? What are the solutions of these lovely little functions below? And again, just a little sketch is all we need here. This is not art, this is math. Let's make a little sketch. Okay, what are the solutions of the function? So again, what are we actually doing when we're solving for x? What are we actually finding? The roots, yes, we're finding the roots or the x-intercepts, also known as zeros. It has so many words, the roots or the x-intercepts. We're finding where our curve crosses the x-axis. So when I look at this first lovely little curve, what are the roots? What are the solutions? Yes, right there and right there, -7 and -5. There are 2 real solutions here, -7 and -5, and these are the solutions for x. When I look at this curve, this lovely little curve, what's its solution? -3. Right there, -3 is the solution. This one doesn't have 2 real solutions. How many solutions does it have? 1 real solution. Okay. Very good. 1 real solution there. 2 real solutions here. What about this curve? No real solutions. Now, it has no real solutions because it doesn't cross the x-axis. Our calculators can find these solutions because they really exist. This one doesn't have real solutions. It actually has 2 imaginary solutions. It has 2 imaginary solutions. When it doesn't have real solutions, it has imaginary solutions, which is totally weird, right? There, it turns out, is a whole nother side of our number system that you didn't know existed. We had all the real numbers like 12 and -37 and 3/5 and radical 2 and pi. These are all the real numbers that we have. But it turns out that there's a whole other side of imaginary numbers. This is the side of the world that electricians live in and electrical engineers. Okay, it's craziness. But it's not that hard. So it turns out we have imaginary solutions, and this is what we need to learn to do. Our calculators can find these. Our job is to be able to find the imaginary solutions. So let's see what that is. First, we want to start with some basics here. Example 1. We want to simplify the radical. Simplify the radical. And I have this very important piece of information right here. Please highlight that. Make it big. Do something to draw attention to it. Simplify the radical. We have the square root of -1 is equal to I. Very important information here. What do you suppose the I represents? Imaginary. Yes, I for imaginary. Very good. Imaginary. It's an imaginary number. Okay? We can actually graph on an imaginary axis. It's very interesting, but we just don't do it. If you're interested, I could show you another time. So, imaginary numbers, we use I to denote an imaginary number, and I is equivalent to the square root of -1. So, here's what we're going to do. We're going to simplify the radical. First, we're going to take apart the negative. So, I have the square root of -28. I'm going to break it apart into the square root of 1 times the square root of 28. -1 times 28 gets me back to where I started with -28. So first I'm just going to pull off the negative, separate that negative. Now my job is to simplify the square root of 28. Simplifying radicals, what we want to do is look for the largest perfect, P-E-R-F-E-C-T, perfect square. Those are those pink numbers on my first page here. We want to look for the largest perfect square we can. So let me look back at my list a second. Here we go. Look at that. I can just fold it up. I knew there was a reason I did that. Okay. All right. 28. We want to break it apart. What is 28 divisible by? 4. Is it divisible by 9? No. 16? No. 25? Definitely not. The largest perfect square it's divisible by is 4. All right? So that is 28 breaks apart into the square root of 4 times the square root of 7. And I still have this square root of -1 out in front. Now you'll notice all these things are connected by multiplication, and that's because -1 times 4 times 7 gets me right back to what I started with, -28. So all I'm doing is factoring. I'm finding the factors, okay? Now we can simplify. Our largest perfect square was 4. What's the square root of -1? I. What's the square root of 4? 2. And I can't simplify the square root of 7. So that one actually just stays the square root of 7. This is kind of awkward. It's totally accurate, but it's a little bit weird. Traditionally, we put the number in front, followed by the letter, and then the radical brings up the rear. So 2i radical 7 is our simplified answer. Okay. So it's an implied multiply, so it does mean 2 times I times radical 7. You don't have to write it, though. It's implied. Here I'm writing it explicitly. It's explicitly stated versus implied multiply. All right. Over here, let's try another. This one's obviously bigger. First thing I'm going to do is pull off this -1. Square root of -1 times the square root of 180. Well, 180 is a pretty big number. And again, my job is to look for the largest perfect square that divides evenly. So I'm going to go flip back to my perfect squares here. Let's see. And you can use your trusty rusty calculator. It's totally fine. Let's see. 180. Is it divisible? Whoops. 180. Is it divisible by 25? No, that's not. I know it's not. Is it divisible by 36? Oh, look at that. It is. It was also divisible by 9. But which one would I choose? They both divide evenly. 36. I want the biggest perfect square that I can find. And so 36 is the biggest perfect square. That's the one I'm going to use. So 180 breaks apart into the square root of 36 times the square root of 5. 36 times 5 is 180. I still have that square root of -1 out in front. There we go. So I found my largest perfect square, And now I can simplify. What's the square root of negative 1? What's the square root of 36? 6. And I can't simplify radical 5. It's kind of a funky form. So we would write 6i, then the radical 5. Okay. All right. Questions on that? Do you think you're always going to find a perfect square that... No. If you had the square root of negative 7, that would be the square root of negative 1 times radical 7. 7 is a prime number. Even if it was a 10. A 10 doesn't have a perfect square that divides evenly either. So the only thing we can clean up is the I part. Okay? So sometimes the numbers aren't really going to simplify much. So keep that in mind. They're not always going to simplify. All right. Questions on that one? Super. Let's move on. Example 2. Solve the equation for all values of x. Solve the equation for all values of x, which is kind of interesting that they put the word all in there. Solve the equation for all values of x. I think they're drawing your attention to the fact that there's probably not just one answer. Okay? When we started, I said we're finding solutions to curves here. And this one has how many solutions? It has no real solutions, but it has 2 imaginary solutions. And that's our job, to figure out these imaginary solutions. There's 2 of them. Kind of interesting. They always come in pairs. Conjugate pairs, opposite pairs, okay? There's always a plus or minus. Plus or minus, and typically write plus or minus like that. So all of our answers for these imaginary solutions always are going to have this plus or minus thing in front. We're going to solve these using what's called the square root method. And to solve using the square root method, which we're going to get way more familiar with later, is the first thing we want to isolate. Isolate the x squared. So that's our first thing we're going to do. I have x squared plus 100 equals 0. What should I get rid of? The 100. So we can subtract 100. That's easy. So we have x squared equals negative 100. And then we're going to take a square root of both sides. And when we do that, we're going to make sure that we don't forget the big old plus or minus. Okay, that's the thing that everybody forgets. So we're going to take now a square root of both sides of our equation. What happens here on the left? It's just x. The square root and the square cancel out. They're inverse operations. They undo one another. It's just x on the left. And over here, we shouldn't forget our plus or minus, first of all. Don't forget the plus or minus. There's always 2 imaginary solutions. And now I just have to simplify my radical. So this is the square root of negative 1 times the square root of 100. What's the square root of negative 1? I. What's the square root of 100? 10. So plus or minus 10i is the solution. 2 solutions, positive 10i and negative 10i. Easy or hard? Let's look here. X squared plus 64 equals 0. What should we do first? Isolate the x squared, so we're going to do what? Minus 64, good. So we have x squared equals negative 64. Then what can we do? Square root both sides. Don't forget the plus or minus. Write that down really big. Don't forget the plus or minus. Write that huge on your paper because that's where you're going to miss something. You're going to forget the plus or minus. The square root of x squared cancels out those exponents and just leaves the x. We have a plus or minus in front. And the square root of negative 64, I can break apart into the square root of negative 1 times the square root of 64. What's the square root of negative 1? I. What's the square root of 64? 8. So plus or minus 8i. In Delta Math, all you need to put in is the plus or minus 8i. You don't have to write x equals ever, unless it's asking for an equation. It's just solving. Questions on that? Okay, very good. Last thing. You're going to be super excited. Example 3. This looks like a ton of work. Huh, slimplify. That's a funny word. I just noticed that. It's my third time. It says slimplify. Okay. All right. Simplify the expression. Okay. To a plus bi form. I have this new tidbit of information here, a very nice little tidbit, that x squared equals negative 1. While you're writing that down, I'm going to talk about where it comes from. I know that I is the square root of negative 1. And if I want to square I would square the I, and I'd square both sides. Well, what happens when I take that square root and square it? It cancels out, yeah. And we're left with just a negative 1. So it does make sense. And you can get there pretty easily. But usually we just memorize that I squared equals negative 1. So you'll notice here we have all kinds of operations that we're doing with imaginary numbers. And these are all imaginary numbers. They're called complex numbers, but I don't think that matters. Right here on letter A, we have negative 11 minus 7i times the quantity 2 plus 6i. We're going to multiply this by hand so you can see how to do it. But guess what? Your calculator can do it, which is great. Okay, so I'm going to show you. Let's start by multiplying first. We're going to distribute the negative 11. What's negative 11 times 2? Negative 22. What's negative 11 times 6i? Negative 66i. You should absolutely write this down. I'm writing it down. You should write it down. It's important. Once upon a time, we used to spend three or so days doing these operations. It's not easy. And then I finally was just like, you got a calculator. So there are some really important things that you have to know how to do, but not right now. Negative 7i times 2. Negative 14i. And then negative 7i times 6i is what? Negative 42i squared. Very good. Negative 7 times 6 is negative 42. I times I is I squared. Very good. And then I'm going, oh, wait a minute. I squared is what? Negative 1. So really, this is negative 42 times negative 1. What is negative 42 times negative 1? Positive 42. So it really just changes the sign of the number, which is quite interesting. All right, so I have 22 minus 66i minus 14i plus 42. It's kind of a wonky plus sign. Okay, and now all I have to do is combine some like terms. Negative 22 and a positive 42 is what? Who wins? The positives by how many? 20. Here we go. 20. And then negative 66i's and negative 14i's is a whole lot of negatives. How many negatives? Negative 80i. And that, ladies and gentlemen, is A plus BI form. A number and another number I form. Complex form. Now that's great. We can do that all day and night. But, my God, we've got calculators. So grab your calculator. You have, on your calculator, a magic I. On the TI, It's above the decimal. Do you see the little I? What color is it? Blue. What does that mean? Second I. You got to use the second function. On the Casio, our I is right at the bottom above the 0. Again, it's a yellow function, so we have to use the shift character. Ladies and gentlemen, go ahead and go to your home screen. On the TI, you can do second quit, and it'll take you to the home screen. On the Casio, I'm going to go to the math menu. Go ahead and type this in. Exactly how it is. Negative with the parentheses and everything. Negative 11 minus 7i, parentheses 2 plus 6i. And what do you get?
20 minus 85.
How about that? Pretty cool. Just clear. All right. Very good. Can you please go ahead and do B and C as well? On the calculator. Yes, on the calculator.
Will you scoot it up a little bit?
On the calculator. There we go. Do B and C. Go ahead. Do it now.
Jeez.
All right, ladies and gentlemen, what did you get for 11? Or, I'm sorry, B. For B. Good. Negative 10 plus 10i. Very good. How do you get the power of 3 on letter C? Caret. Yes, there's that little caret symbol, the little arrow thing. Caret 3 there. All the calculators have that little caret 3. And what do you get for letter C? Good. Negative 11 minus 2i. Negative 11 minus 2i. Very, very good. All right, I want to talk about D. What operation are we doing on number D here? Division. Very good. So this big giant bar really means division, okay? And the way that it's written is that it's actually an implied grouping symbol. It's really important that you understand that because it's this big long bar, it's saying, hey, you need to simplify the numerator and then do the denominator. You need to use parentheses when you enter that in. So go ahead and type that in and see what you get using parentheses. You will most likely get the wrong answer if you don't use parentheses. Right. What?
Love parentheses.
Love, yes.
If you use more parentheses than you need in the calculator, chances are you'll be okay.
All right. Did you get an answer? We get, what'd you get? Negative 1 plus 2i. Fantastic. Okay, here's the issue. We have one issue, and that issue is that it doesn't work all the time. And I apologize. I didn't realize this in the Delta Math. I'm just going to say if you get a weird one, just get it wrong. Simplifying this by hand is very difficult, okay? So let me show you one. Negative 3 plus 21i over 9 minus 4i. Will you try that one? Negative 3 plus 21i over 9 minus 4i. You got something totally crazy, right? Cray. 9 minus 4i, okay? Totally ugly, crazy decimal. Ladies and gentlemen, sometimes you're going to get not so nice fractions. But guess what? Your calculator has a convert to fraction option. So on the TI, if that's your last answer, all you have to do is math bracket. So you go to the math menu, you press math, And convert to a fraction is your first choice there, number 1. And you see it's going to pull the previous answer and it's going to convert it to a fraction. And that's what that means. Just hit enter. And there you go. Yeah, it's not ugly, but it's there. So you're going to math frac it. So you can absolutely try math frac. That's a great thing to use. And on the Casio, same thing. I have a fraction decimal button. So you just get to press the fraction decimal button and it'll convert it. Okay. FD. Oh, nice. Okay, ladies and gentlemen, get started on your delta math, okay? If it doesn't work, if you can't convert it to a fraction, again, I'm going to apologize and say it's not going to happen on test day. Just miss it on the assignment and try again. I'll give you one that works right.